Hello my dear friends, I am Shubham from Learner Hub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnerhub.com. So then, let's start. So students, in this video we are going to continue studying the concepts of your chapter Atomic Structure and Chemical Bonding, which is of your ICSE Chemistry class 9 chapter number 4, right? So before this video, okay, in the previous two videos we have covered the concepts of atomic structure and the concepts of ionic bonding. So if you have missed those two videos, please do watch them, because if you would have the building blocks of the atomic structure as well as understanding of ionic bonding, then it would be pretty much easier for you to understand the concepts of covalent bonding, which we are going to study in this video. Okay, also at the end of this video we are going to see some questions so that you would get a fair idea how much you have understood the concepts, right? So without wasting much time, let's start and let's rock. Okay, so what all things we are going to study in the covalent bonding? Okay, this child is saying let's have a look over it very quickly. So we are going to first understand what is covalent bond, then what are covalent compounds and covalent molecule, then the types of covalent bond, very much interesting, and then atomic orbit structures of first covalent molecules, okay, H2Cl2O2 N2, and then we are going to see the atomic orbit structures of covalent compounds like HCl, H2O, NH3, carbon tetrachloride and methane. Okay, so let's start first understanding what is a covalent bond. Okay, so I will help you understand this, what is actually a covalent bond, with a simple story. Fine. So suppose there are two friends. Okay, now I'm just drawing the heads of those two friends. Okay, fine. See, because drawing an entire body takes time, so these are two heads, okay, of these two friends. Now these two friends, okay, suppose their names are atom A and atom B. Okay, so now these friends have become atoms. Actually I wanted to tell you that there are two atoms, right? But to make some twist in the story, so these both atoms, atom A and atom B, okay, they are having some number of electrons, okay, but they want some more number of electrons to complete the octet in their valence shell. Okay, now we all know what is this octet in valence shell. Octet means simply to have 8 electrons in their outermost shell. Okay, the meaning of this term. So for that, but the problem is here. Now see, this atom A and this atom B, okay, both of them have 1 electron each. Fine. In their outermost shell, okay, as we can say, or we can say that, okay, they are having, 7 electrons each, not 1, by mistake I said 1, okay, 3, 6, 7, okay, 3, 6, 7, okay. So both of them are having 7 electrons. Now they are like short of only 1 electron, okay, for having 8 electrons in their outermost shell. I have only drawn their outermost shells, okay, not the inner shells and nothing like that. Now the problem here is both of them want 1 electron, but now no one is ready to give up an electron. Okay, neither atom A nor atom B. Same like you and your best friend. Suppose you are atom A, your best friend is atom B. Both of you want that one single chocolate, but neither of you is trying to give that one single chocolate completely to the another one. Okay, you're not feeling to give to your best friend. Okay, your best friend is also not feeling to give that entire chocolate to you. So what you do is you share that chocolate. So in the same manner, what these two atoms do is, what they think, see, I am having 7 electrons, you are having 7 electrons. What we will do is, I will share my 1 electron with you. You share your 1 electron with me. So what would happen? Okay, they would come closer then. Now in this way, you just imagine, in this way they are coming closer. This atom A, and here this is the atom B. Okay, here are the remaining 6 electrons. I'm just writing here 6 electrons. Okay, here are the remaining 6 electrons of these atom. Here are the remaining 6 electrons of this atom. Okay, now the 1 electron here and 1 electron here, okay, of both their atoms. They are telling that we are going to share this 1 electron, okay. This atom is going to share this 1 electron of its own with this atom. This atom is going to share this 1 electron, okay, of its own with this atom, okay. So this is going to be shared. Now what they do is, this 6 electron, okay, suppose they are here only, but due to this both electrons, okay, now which are now shared, okay, shared. So here there is a pair of electrons, right. So I can say 1 pair of shared electrons, 1 pair, okay, 2 electrons of shared electrons. Now what is happening? See, 6 electrons, 7 and 8th electron, it got its 8th electron, okay, this atom A. And in the same manner, this atom B, 6 electrons, 7 electrons of its own, but now because of sharing of this electron from this atom, okay, now this atom has got 1 more electron, okay. So it also has now 8 electrons in its outermost shell. Clear? So because of this sharing, both of them attained the octet in their valence shell. And when such type of sharing of electron pairs, okay, here there is sharing of 1 pair of electron, there can be sharing of 2 pairs, there can be sharing of 3 pairs. So when such type of sharing of electrons take place between the atoms, okay, and in this manner when atoms combine, okay, there is now a force of attraction between these 2 atoms, okay, the same like that of we have studied when the electron is transferred from one atom to another atom, okay, there arises a force of attraction between the atoms. So in the same manner here, when the electrons are shared between the 2 atoms, okay, electron pairs are shared between the 2 atoms, the force of attraction arises between these atoms, and now these 2 atoms start to love each other, okay, they start to they start to have the affection with each other. And now this force of attraction, okay, which is holding these 2 atoms, okay, so this force of attraction we can call it as chemical bond, right, because we know what is a chemical bond. Chemical bond is simply a force of attraction which holds together the constituents in the chemical species. So here also the force of attraction is holding the atoms together in this chemical species AB. So this is a chemical bond. Now whenever such type of chemical bond is formed because of mutual sharing of electron pairs, okay, mutual sharing. How mutual? Why I'm saying mutual sharing? Because both of them have shared the electrons, okay, both of them have contributed to the shared pair. This atom is also giving its electron to the shared pair of electron. This atom is also giving its electron to the shared pair of electron, okay. The shared pair of electron is not coming from one single atom. The shared pair of electron is being contributed by both the atoms, okay, 1 electron each, okay, in the pair from the atoms. So such type of sharing is mutual, because this is also sharing its electron, so mutual sharing. So such type of mutual sharing, okay, when it takes place and when the chemical bond forms, such chemical bond is called as covalent bond. As simple as that, okay. So once you understand the story, you have this definition in your brain, okay, of chemical bond, of covalent bond. What is covalent bond? So whenever a chemical bond is formed by mutual sharing of electron pairs, okay, between the 2 combining atoms, chemical bond formed by mutual sharing of 1 or more pairs of electrons, okay, or 1 or more electron pairs, right, whatever I said just now, chemical bond formed by mutual sharing of 1 or more electron pairs, okay, between 2 combining atoms. So this chemical bond is called as covalent bond, okay, or such type of chemical bond is called as covalent bond. Which type of chemical bond? Which is formed by the mutual sharing of electron pairs between the combining atoms. Clear? Very easy, very easy. Now see, covalent compound and covalent molecule are like the, once you understand how covalent bond is formed, covalent compound is simply the compound, okay, the chemical compound which is formed, okay, when there is mutual sharing of 1 or more electron pairs between the atoms, okay. So now in the same manner, I have taken the example, right, of atom A and atom B. Now here there were 6 electrons. Here in atom A there were 6 electrons on this side. 1 electron of A is shared with B, this one, okay, suppose I'm writing it with red, and 1 electron of B is shared with A, okay. So this is a shared pair of electron. So whenever a chemical compound, like suppose AB, here chemical compound AB is formed, okay, because atom A and atom B are getting combined, okay, so they are resulting into the formation of a chemical compound AB. So whenever a chemical compound is formed by the mutual sharing of electron pairs, this chemical compound, we can say it is a covalent compound. right? Chemical compound formed by the mutual sharing of electron pairs between the combining atoms. Okay, so such chemical compound is covalent compound. Then what is a covalent molecule? As simple as that, the same thing. Whenever a molecule is formed by the mutual sharing of electron pairs between the combining atoms, or between the atoms which are resulting into the which are the part of a molecule, okay, then we say that this molecule is a covalent molecule. Okay, molecule formed by the mutual sharing of pair of electrons between the combining atoms. Clear with what is a covalent molecule? So what happens is, many a times students get confused with covalent compound and covalent molecules. Okay, now what you would do is, I will ask you some question, you would answer me. Okay, so here I am writing some species. Now I am going to tell you that yes, in those species, I am telling you, in those species there is a presence of covalent bond, which means simply in those chemical species, okay, the atoms are combined, okay, by the mutual sharing of one or more pairs of electrons between the atoms. Okay, but now tell me, out of these species, which are covalent molecules and which are covalent compounds. Okay, be careful. So here I am writing, see, these are the 4 species. Okay, now if you are like, if you have understood the concept, okay, and if you would try a little bit, okay, scratch your heads, you would get the answers. Okay, but I will tell you the answers. Okay, suppose you would have paused the video, okay, and you would have thought, given a thought about, you would have thought what would be the answers, okay, and try to solve it. Well and good, very good, you should try. Okay, so I hope you would have tried. Then let's come back to the answer. So see, here I am telling you that every chemical species here, it is having a covalent bond. I have told you already. This means that it is having the mutually shared pair of electrons between the atoms. Okay, so now this is a molecule, this is also a molecule, this is also a molecule, this is also a molecule. We all know these all are molecules. This is hydrogen molecule, this is ammonia molecule, this is water molecule, this is chlorine molecule. So every single thing is a molecule. So every one of them is a covalent molecule, right? Because covalent molecule is simply a molecule, okay, which is formed by mutual pairing of shared pair of electrons between the atoms. So I have already told you, all of them are having mutually shared pair of electrons. Okay, so all of these molecules are being formed by mutual sharing of electron pairs between the atoms. So these all are covalent molecules, first of all. Okay, now see, I am writing here covalent molecules, all of them are there. Okay, but out of this covalent compound, now we have to just understand a very basic difference. Okay, that compounds are made up of atoms of different elements. So see, it's nothing to do with the concept of covalent bonding here. It's very simple thing which you have already studied from your class 6th, that compounds have the molecules, or the molecules of the compounds have atoms of different elements. So here in hydrogen molecule, are the atoms are of different elements? No. So this is only a covalent molecule. This is not a covalent compound. But here ammonia, yes, it is absolutely a covalent molecule, and also it is a covalent compound as well, because here it is having, here its molecule is having atoms of different elements. Right? Same way, water is also a covalent compound along with being a covalent molecule. And chlorine molecule is simply a covalent molecule. Okay, same reason as that of the hydrogen, because its molecule is not made up of atoms of different elements. Okay, so very simple question. That's the reason, or this was the reason, because students often get confused. I have introduced this small 2 concepts or small 2 parts of what are actually covalent, means to make you understand the difference between the covalent compounds and covalent molecules. Okay, clear? Now let's move ahead and see what are the types of covalent bond. Okay, so here we know covalent bond simply means this is the bond, okay, which is formed by mutual sharing of electron pair between the atoms. Correct? So if the atoms here, if they are sharing only one pair of electron with each other, okay, one pair of electron, so then we say that that type of covalent bond is a single covalent bond. Clear? Very simple. And we denote this by a simple line, single line, horizontal. Okay. So if suppose atom A and atom B is having, suppose if I've been told that atom A and atom B is having a single covalent bond, then how I will just show it? Between A and B, I will just show a single horizontal line. Now, another scenario, if the covalent, if a chemical bond is formed, okay, by mutual sharing of two pairs of electrons. Okay, this one pair, this two pair, these are the two pairs of electron which are being shared. Okay, so now we know such type of chemical bond which is formed by the mutual sharing of electron pairs between the combining atoms, it's covalent bond. But now this covalent bond, okay, is having two pairs of electron. This means that this is actually a double covalent bond. Okay, when only one pair of electron is shared between the combining atoms, it is a single covalent bond. So in the same way, when two pairs of electrons are shared, it is a double covalent bond. Clear? Now how to represent it, or how you can denote it between the two atoms? By simply two horizontal lines. Okay, that's it. And then triple one, I hope you would have guessed it right. Whenever three electron pairs are shared, okay, so that covalent bond is called as a triple covalent bond. Okay, denoted by these three horizontal lines. Very easy. And how to denote it? Between A and B, suppose there is a triple covalent bond, then A and B, and between three horizontal lines. Clear? Very easy thing. So these all things are necessary for you to understand how to draw the atomic orbit structures of covalent molecules and covalent compounds, and to understand how these covalent molecules are formed and covalent compounds are formed. Okay, so now let's see how these covalent molecules and covalent compounds are formed. Okay, so along with understanding the formation of these covalent molecules and covalent compounds, we are also going to understand, or we are also going to learn how to draw the atomic orbit structures, how to draw their atomic orbit structures. Okay, fine. So starting with very simple thing, very simple example, which is hydrogen molecule. Okay, so this is a covalent molecule, right? Okay, because here it is having a covalent bond, and since it is a molecule which is made up of only same type of atoms, or only atom of one element, so it is a molecule, simply a molecule. Okay, not a compound, right? So H2, covalent molecule. Now moving ahead, how to draw the atomic orbit structure and how it is formed. So see, before the hydrogen atoms, two hydrogen atoms combine, how they look like? Simply, here is the nucleus of hydrogen atom. I am just denoting this with a simple small, with a simple H. Okay, this is the nucleus. Same like that of, we have drawn the atomic orbit structures for ionic compounds like NaCl, MgCl2, calcium oxide. So in the same way, we are going to do the thing. Just the basics would remain the same. Slight differences in the orbit structures you would observe. Okay, now what are those differences? Let's see. Okay, so first the nucleus denotion, or nucleus, how to draw it's the same thing. Okay, same as that of the ionic compounds, atomic orbit structure. And then shell. So hydrogen is only having one shell, and in this one shell it is having only one electron, right? It lacks neutron. So this is a very basic thing. No connection of neutron here, but still I have told you this thing. Now another hydrogen atom. So this is the nucleus, this is the first shell, and this is the only electron. Now both the hydrogen atoms, see, just like the other elements atoms, okay, they also want to become stable. But now for becoming stable, other elements atoms, what they do, they try to attain octet in their outermost shell. But here hydrogen atom is only having one shell, and it's only one shell. Okay, the first shell is having the maximum capacity of accommodating only 2 electrons. So no question of attaining octet for the hydrogen atoms, because its shell cannot accommodate only that 8 electrons, maximum 2 electrons. And once it attains this maximum 2 electrons, okay, or one more electron in its shell, what happens is it is attaining the noble gas configuration of the nearest noble gas to the hydrogen atom. Okay, so what is the nearest noble gas to the hydrogen atom? After hydrogen comes helium, right, having atomic number 2. This is having atomic number 1. So this is a noble gas, and its configuration, if I would write, it is simply just 2, only one shell and 2 electrons in that shell, because atomic number is 2, right? So we know atomic number is number of electrons in the neutral atom. So here this means that atomic number is 2. So there are 2 electrons in the neutral atom of helium. So just 2 electrons are being distributed in the first shell. That's it. This is the electronic configuration. Now, when hydrogen atom attains or gains or is in the quest of this one more electron, and once it somehow manages to get that one electron in its shell, okay, how much electrons become in this shell? In its only shell, 2 electrons. So now these 2 electrons in the first shell, with these 2 electrons in the first shell, it is attaining the configuration of nearest noble gas, which is helium. And we know other atoms also do indirectly the same thing. By attaining the octet of their valence shell, they indirectly attain the nearest noble gas configuration. So in short, attaining octet in the valence shell or attaining nearest noble gas configuration makes the atom stable. This is the concept, right? So here hydrogen cannot attain octet, but yes, it can attain the nearest noble gas configuration, and thus it can become stable. So it wants to do the same thing. Now what it wants one electron, desperately one electron in its outermost shell. But this also atom wants the same one electron. Now what they would do? The same chocolate wala story. Okay, they would share their only electron. So here this electron and this electron, okay, this hydrogen atom shares its only electron with this hydrogen atom. This hydrogen atom shares its only electron with this hydrogen atom. And in this way, what they do is, after sharing, okay, there is a shared pair of electron then, and now this hydrogen atom, see, I will show you how. So this is the before combination diagram of atomic orbit structure. Now see, I am writing here before combination. Okay, now what happens after combination? Let's see how to represent the diagram or how to show what has happened. So see, this is the hydrogen nucleus of one atom. This is the hydrogen nucleus of another atom. Okay, now what would we do? What we are going to do is, since the electrons in this shell are getting shared now, so we are going to overlap the shells like this. Okay, so I have overlapped the only shell of hydrogen in this way, and when you overlap the electrons which are getting shared now, okay, see, let me erase it. What I have done is, the overlapping is like very small. So now it would be very clear. Fine. So this is the overlapping of their only shells, and once they have shared the electrons, okay, we denote this sharing of electrons like this. We overlap the outer shells and we write the electrons here inside. Okay, so now we say that this hydrogen atom has now 2 electrons, okay, in its shell, and this hydrogen also has the 2 electron in its shell. So both of them have attained the nearest noble gas configuration and thus have become stable. But in process, what has happened is, they have shared the electron pair. So this is a mutually shared electron pair, and whenever now this results into the force of attraction, right, correct, between these two atoms. And this force of attraction, okay, we call it, which is holding these two atoms, we call it as chemical bond. And such a chemical bond which is formed by the mutual sharing of electron pairs is covalent bond. So this has resulted into the formation of a covalent bond. Now this covalent bond, okay, has one shared pair of electrons. So what we call such covalent bonds? Single covalent bond, right? So we say that in a hydrogen molecule there is a single covalent bond. Okay, in H2 molecule there is a single covalent bond. So this is the atomic orbit structure for hydrogen before combination. This is after combination. Okay, so yes, before moving ahead, now a very small correction. See, instead of writing this E, you can just simply make a circle, means denote the electrons with solid dots, okay, or like circles or crosses. Okay, so you can use the symbols in short, okay, but you try to use these simple symbols like dots or solid circles, means or circles simply, or like crosses, okay, instead of writing E and all those things. Okay, so simply this one change, that's it. Okay, denotion of electrons. Now interesting thing, when we are showing the electrons, okay, of the same type of atoms, then you can show, you always show it with the same symbols, okay, because this is also hydrogen atom, this is also hydrogen atom, so electrons are also means like same, so that's why we will just show the electrons with the same symbols. But moving ahead, when we would show the covalent bond between different atoms, so at that time we will definitely, okay, take care of one thing, that the symbols of the electrons of different atoms would be different. Okay, for now it's very fine, very much fine. So now moving ahead to the chlorine. Now same story again comes back. Chlorine molecule, okay, in this chlorine molecule the chlorine atoms are combining, but how they are combining, let's try to understand it. So first of all, let's draw the before combination atomic orbit structure diagram for chlorine. Okay, so drawing the nucleuses, then first shell, second shell and third shell. First shell, second shell and third shell. Fine, 3 shells are there for chlorine because electronic configuration for chlorine is like 2, 8, 7. Okay, so 3 shells involved. First shell has 2 electrons, second shell has 8 electrons, and the last shell has 7th electrons. But now what we are going to do is, in this atomic orbit structures for covalent molecules, we are not going to consider the shells which are inside. Okay, we are only going to focus on the shells which are the outermost shells. Okay, no need to draw the shells which are inside. Okay, or no need to show the electrons which are present in the inner shells. Okay, so simply what we are going to do is erase these 2 shells. Fine, so this is now a depiction of chlorine nucleus and the outermost shell of the chlorine. Now whatever electrons are present in this chlorine atom's outermost shell, that we are going to show. So since same atoms are there, so same type of denotions we will use. Okay, now what you do is try to denote it in the pairs. Okay, so suppose 7 electrons are there, so this means that in these 7 electrons, if I would denote the, or if I would draw the electrons, okay, on the shell, so I would draw in pairs. So out of 7 I can make 3 pairs of 6 electrons, and 1 electron would be like, I would draw it separately. So here 2 pairs, again on this side 2 pairs, and on this side 2 pairs. Okay, so 6 electrons, and then this is 1 electron. Okay, remaining 1 electron, the 7th electron, again the same thing here, 2, 4 and 6. Okay, and the 7th electron here. Okay, I will try to make use of a different color so that it is more visible to you, right? Sometimes these dots are not like pretty clear of the same color. Fine, chalo. Now what is going to happen here? Both of them are desperately in need of 1 more electron, okay, so that their outermost shell gets 8 electrons and they attain the octet in their outermost shell. Okay, and they become stable. Okay, also indirectly I can say that after getting 1 more electron for each of the chlorine atom, it is attaining the configuration of its nearest noble gas, electronic configuration of its nearest noble gas, which is argon. Okay, simply argon, 2, 8, 8. Okay, so see, just one electron it wants in its outermost shell. Once it attains its octet, or once I can say it attains the electronic configuration of its nearest noble gas, it becomes stable. But for that it wants 1 electron. Both of them want 1 electron, but both of them are not ready to give that 1 electron to each other. So again the same story, they will share that electron. Okay, so this chlorine, okay, atom would share this electron with this chlorine atom. Okay, this one. And this chlorine atom will share this electron with this chlorine atom. Okay, and then what would happen? There would be a shared pair of electrons. So how we would show it? This was the before combination, and then after combination, see what would happen? The same type, the same thing, chlorine nucleuses. Okay, this is the outermost shell of chlorine. Okay, this is the outermost shell of the different chlorine atom, another chlorine atom. There is an overlap, you can see. Okay, and in this overlap, these 2 electrons would fit in. Okay, so here I will show it with a different color, like this. This is 1 electron, this is another electron. Okay, these 2 electrons which are shared. Okay, now remaining 6 electrons as it is, for both the atoms. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Now for yourself only you count. Okay, now this chlorine has 6 electrons and 7, 8 electrons in its outermost shell. This chlorine has 6 and 7, 8 electrons in its outermost shell. Okay, so because of this sharing agenda, both of them are attaining the octet, both of them are, or I can say, attaining the electronic configuration of nearest noble gas, and thus becoming stable. And due to this, sharing of electrons. Okay, here there is a force of attraction between these two atoms, so there is a formation of chemical bond, and this chemical bond, which is formed due to the mutual sharing of electron pairs, it is called as covalent bond. So here covalent bond is formed, and since there is sharing of one pair of electron, so we say that this is a single covalent bond. Okay, so from here after, I am not going to tell again and again. Whenever you see there is a sharing of electron between the two atoms, there is a formation of covalent bond, right? So I hope it is now pretty clear till this point. Since the things are new to you, I tried to make it like very much pretty easier in the initial stage. Okay, but now since now the things are going to repeat again and again, so I have already told you I am not going to repeat again and again the same thing, that whenever the bond is formed by the mutual sharing of electron pairs, it is a covalent bond. So whenever now you would see such things happening, the mutual sharing of electron pairs between the combining atoms resulting into the formation of bond, it is a covalent bond, right? Okay, now moving ahead to the oxygen molecule. So it's now slightly different, okay, than the hydrogen and the chlorine molecules. Okay, so let's try to understand this thing. See, oxygen atoms electronic configuration we would start with first, okay, because two oxygen atoms are getting combined. So oxygen atoms electronic configuration, atomic number 8, electronic configuration is 2,6. Okay, now here I would draw two oxygen atoms. This is the nucleus, this is the outermost shell of the oxygen atom, this is the nucleus, this is the outermost shell of the oxygen atom, right? I'm going to show 6 electrons in its outermost shell because in electronic configuration it is 6. So 6 electrons like this. Okay, now I'm drawing this like this dots. Okay, 1 2 3 4 5 6. Okay, or like, yes, I can show this 2 to this side. Okay, this 2 to this side. Now you would say, sir, why you are doing this? I will tell you. Okay, you would get to know in few minutes. So 1 2 3 4 and then 5 6. Okay, so 6 electrons, fine, 6 electrons depicted. But now both of them, like, they are short of 2 electrons, just 2 electrons from their nearest noble gas configuration, which is of neon. Okay, or in order to complete their octet, they are short of 2 electrons simply. So both the ways, okay, both the ways I'm trying to say that they want to become stable. You all know, for that they need 2 electrons, as simple as that. Each atom needs 2 electrons, but neither of them is ready to give that 2 electrons completely to the another atom. So what they would do, they would share the 2 electrons. Correct, you heard it right, they would share the 2 electrons now. Okay, so each oxygen atom here, it would share this 2 electrons with this oxygen atom. Here this oxygen atom would share this 2 electron with this oxygen atom. Okay, now in turn, after sharing, okay, they would combine with each other. And how they would combine now? The same type of diagram. Oxygen, outermost shell overlapping with the outermost shell of another oxygen atom. And here the remaining 4 electrons of each oxygen atom are as it is, present as it is. Here 1 2 3 4. So here 1 2 3 4. Here 1 2 3 4. So here 1 2 3 4. Correct. Now these 2 electrons of this oxygen atom, these 2 electrons of this oxygen atom are being shared. So I'm just going to write the electrons in front of each other like this. 2 dots, 2 dots in this way. 2 dots, 2 dots. Okay, making a pair, making a pair. Okay, this is making one pair, this is making another pair. Okay, the pair of, see, in this pair, this electron is of this atom, this electron is of this atom, right? So mutually shared pair of electron, correct? Here in this pair, this electron is of this atom, this electron is of this atom. So again, mutually shared pair of electrons. Okay, so in the electron pair, each electron is getting shared by each atom. Okay, so that is called as mutually shared pair of electrons. I have told you. So I hope you would have understood this thing. Okay, so here there are now two mutually shared pair of electrons. Two mutually shared pair of electrons. Clear? So this is a covalent bond formed here between the oxygen molecule, and since two mutually shared pair of electrons are there, so here this is a double covalent bond. Okay, I'm just writing the symbols. Okay, you just write in the words, double covalent bond. Clear? Before combination, after combination. Very simple. In the similar manner, now you try to think on your own how nitrogen atoms would combine to form a nitrogen molecule. Okay, like its type of formation is the logic, the reasoning, the method of formation is absolutely the same as that of the hydrogen, chlorine and oxygen. Okay, but there would be a slight change in the, I'm going to give you the hint right now, okay, in the pair of electrons which are going to be shared. Okay, so try to apply your brain. Okay, the same logic, the same thing. Fine. So if you would have tried something by pausing the video here, okay, I hope you would have tried by pausing the video, and maybe you would have reached somewhere, some or the other place, if you have drawn the correct atomic orbit structure of nitrogen molecule, if you have understood how correctly it is formed, well and good, superb. If not, no worries, I'm going to tell you right now. Okay, chalo, so let's start. Nitrogen atom, then here this nitrogen atom, okay, but yes, I would, whenever I'm telling you that you pause the video here and you try it on your own, you definitely give it a try. Okay, definitely, because what would happen because of this? Okay, you are trying to make your brain work. Okay, instead of sitting like a couch potato and watching me telling everything, each and everything to you, you on your own, after studying some things, after learning the basic concepts, if you try to make your brain run, it can start running. Okay, you would start using your brain. Okay, and then you would little bit enjoy more. If you are getting right, if you are getting wrong, no problem. We are here to learn, right? So no issues in making mistakes. If you are making mistake, you just learn the right thing, and you just you can become again happy. Okay, and again try. Okay, because making mistakes is not a big deal. Trying is, yes, very important, and not making the same mistakes is a big deal, right? So again, come back to the concept. Okay, leave the philosophy for now ahead, means to the side, keep it always in your brain. But yes, now coming back to the concept, your nitrogen molecule is having nitrogen atoms. Okay, 2 nitrogen atoms getting combined. So nitrogen, we will start with the nitrogen atoms electronic configuration, which is here atomic number 7, electronic configuration 2,5. Fine. Now then I am going to draw the nitrogen atoms nucleus and the outermost shell of the nitrogen atom. Here again nitrogen atoms nucleus, outermost shell of the nitrogen atom. Outermost shell is having 5 electrons. So now what I'm going to do is, I know that for nitrogen, okay, to attain octet, it needs 3 more electrons. Correct? This nitrogen atom. And this nitrogen atom also needs 3 more electrons. But they are like very much adamant that they would combine with each other itself. Okay, they are saying that like we are best friends, man. We cannot get departed. Okay, there is a huge affection between us. So like I want to make a bond with you only. Both of them are saying to each other. Okay, but then if this is the case, then they again need to find a way to complete their own octets. Okay, now if this is the case, so then how oxygen atom did, since it was short of 2 electrons, okay, what it did was it shared its 2 electrons with the other oxygen atom. So here nitrogen, since it is short of 3 electrons, it can do the same thing, right? Can it? Yes, it does the same thing. It also shares its 3 electrons with the another nitrogen atom. Okay, now what would happen? See, here these are the 3 electrons in the outermost shell of nitrogen atom. Here these are the 3 electrons in the outermost shell of the nitrogen atom. Okay, remaining are 2 electrons, right? So I'm just drawing it here itself. 2 electrons here, 2 electrons here. Okay, but when they would share these 3 electrons, okay, this electron, and this electron, 3 electrons of this nitrogen atom getting shared with this nitrogen atom, and then this electron, and this electron, 3 electrons of this nitrogen atom getting shared with this nitrogen atom. Okay, what would happen? See, after getting combined, see, here nitrogen's nucleus, 2 atoms, here there is an overlap I'm showing between the shells, and these 2 electrons, since not involved in sharing, they would be just like simply sitting here on the top of the nitrogen atom. Okay, I'm just joking. This 6 electrons or these 3 pairs of electrons which are shared. Okay, now since see, this electron pair, this electron pair and this electron pair, and now no need to tell you again, these are mutually shared pairs, because in this pair this electron is from this atom, this electron is from this atom, and the same applies for another 2 mutually shared pairs. Okay, so this 3 mutually shared pair of electrons, I'm just denoting it in this way, 1 2 3, 4, 5, 6. So 3 mutually shared pair of electrons. Now you count it for your own self. Okay, see 6 electrons here itself in the outermost shell and 7, 8 for this nitrogen atom. For this nitrogen atom also 6 electrons here itself and then 7, 8. Who? Wow, they have completed their octet, right? And in turn shared 3 electron pairs. Okay, so they have in turn formed a covalent bond between them. Now this covalent bond is having since 3 shared electron pairs, so this is a triple covalent bond, right? So was it similar like that of oxygen, right? Okay, so now students, let's move ahead and see how our HCl molecule is formed, okay, with and also try to understand how to draw its atomic orbit structure. Okay, so the basic concepts are going to be remain exactly the same as we have seen the formation of hydrogen, chlorine, nitrogen, oxygen molecule. Same things are going to be remaining, just there would be, okay, you need to take some few care when we are drawing the diagram itself. Okay, that's it. And the sharing, okay, which is going to take place between the atoms, you need to understand it like slightly with more attention. Okay, so see, first of all, let's start with this molecule HCl. So this is made up of hydrogen atom and chlorine atom, correct? So we need to start with their electronic configurations then. So hydrogen is 1, so electronic configuration 1, we all know. Chlorine is 17, so electronic configuration is 2, 8, 7, right? Now let's draw their atoms. So hydrogen nucleus and its only shell having only electron. So now here I am denoting its only electron with this dot. Okay, similarly in the same way, okay, let me make this electron in another color, fine. Okay, then again chlorine. So chlorine's nucleus, okay, just the last shell we have to draw. So the last shell, okay, third shell having 7 electrons. So 7 electrons. Now here we need to take care that the electrons which we are showing for chlorine, they should be depicted with a different symbol. That's it, simply from that of the hydrogen atom's electron. Okay, because the elements, because the atoms are different, atoms are of different elements, right? So in order to distinguish between the electrons, okay, which electron is of hydrogen, which electron is of chlorine, we are doing this, the simple small thing. Okay, depicting the electrons of atoms of different elements with different symbols. So 7 electrons, so 2, 3, 4, 5, 6, okay, and this is the 7th electron. Now the logic remains the same, the concept remains the same. Both of them want to attain their nearest noble gas configurations. Okay, right, this is the main basic thing. Every atom here, when it is forming a covalent bond, when it is forming an ionic bond, it wants to attain the electronic configuration of its nearest noble gas. So here hydrogen wants to attain the electronic configuration of helium. We all know, we have already seen this thing when we were studying the formation of H2 molecule, right? Chlorine here wants to attain the electronic configuration of argon, right? 2, 8, 8 argon. And here hydrogen wants to attain the electronic configuration of its nearest noble gas, helium 2, right? So from this we can clearly see it is short of 1 electron here, okay, when it wants to attain the electronic configuration of its nearest noble gas, hydrogen atom. Okay, similarly chlorine atom is also short of 1 electron, okay, of its nearest noble gas electronic configuration, correct? So both of them desperately want 1 electron, okay, but neither of them again is ready to give up the electron. So what would happen? They would share their 1 electron with each other. So hydrogen atom shares its only electron, okay, it's only 1 electron with the chlorine atom, and here the chlorine atom shares its 1 electron with the hydrogen atom. In turn, what would happen? Because of the sharing of these 2 electrons, there is a sharing of a electron pair. Okay, so here there is a mutual sharing of electron pair. This would result into formation of a covalent bond, right? Now let's show this covalent bond. So hydrogen's nucleus overlap, and here chlorine's nucleus, okay, hydrogen's electron with the dot, and chlorine's electron with the cross, okay, and then remaining chlorine electrons 1, 2, 3, 4, 5, 6, okay, Clear? So 6 electrons, shared pair of electron, shared pair of electron. So hydrogen attaining its duplet, which means 2 electrons, okay, in its only shell, okay, duplet. See, 1 2 hydrogen, very happy, attaining the electronic configuration of its nearest noble gas helium, becoming stable. Chlorine 1 2 3 4 5 6 7 8, attaining octet or reaching its nearest inert gas, nearest noble gas configuration, thus becoming stable. Okay, so both of them have become stable by sharing a pair of electron, by forming a covalent bond. Now this is one shared pair of electron between two atoms, so covalent bond is a single covalent bond. Very simple, very same logic. Okay, moving ahead, ammonia. So now in case of ammonia, again we need to apply the same concept, same logic. Ammonia is having, okay, nitrogen atoms and hydrogen atoms. Okay, but one nitrogen atom and 3 hydrogen atoms. Now hydrogen atom, now I'm not going to write it again and again and over and again. We now already know it is short of its nearest noble gases helium's configuration by 1 electron. So it wants, these 3 hydrogen atoms desperately want 1 electron. Okay, the logic. Now nitrogen atom, you have also seen that when we were studying the formation of N2 molecule, we have seen that nitrogen atom is short of 3 electrons from its nearest noble gas configuration, neon. So it is short of 3 electrons. Now we will think, okay, how to, sorry, it is short of 3 electrons. Here, let me show the arrow correctly. Now we will think how these 4 atoms, 1 atom of nitrogen, 3 atoms of hydrogen, are going to do something that they are going to make each other stable. Okay, so here see, these 3 hydrogen atoms desperately want 1 electron. This 1 nitrogen atom desperately wants 3 electrons. So can they do this way? Okay, can they, means like have such type of arrangement, okay, which I'm now going to draw. See, this is the nitrogen atom, this is the outermost shell of nitrogen atom having 5 electrons. Okay, so I'm going to show these 2 electrons here, okay, with a different color, this 2 electrons here, and then it's 3 electrons like this, okay, on the 3 sides. You will come to know why I'm doing this. Okay, this 1 nitrogen atom, fine, 5 electrons in its outermost shell because nitrogen's electron configuration 2, 5, and short of 3 electrons for attaining its nearest noble gas configuration. Here 3 hydrogen atoms, so I'm going to draw the 3 hydrogen atoms in such a way that they are like in front of these 3 electrons, okay, respectively. So this is the hydrogen atom, this is the hydrogen atom, tweak, and this is the hydrogen atom, choing, in this way. Okay, now showing the electrons of each hydrogen atom. So this is the only electron of hydrogen atom, this is the only electron of hydrogen atom, this is the only electron of hydrogen atom. Okay, oh, they are like very closer to each other, let's make them far. Okay, please hydrogen atom, please don't come so much closer to the nitrogen atom. Okay, I'm just joking. Chalo. So here, fine. Now you can see on your own, I have made some arrangement. Okay, I have got a solution by which all these 4 atoms would become stable. That means they would attain their nearest noble gas configuration. How? Let's see. See, this nitrogen atom is sharing this electron with this hydrogen atom, right? You can see, just pay attention to the tip of my pen, okay, which I'm pointing to. Then this hydrogen atom is sharing this electron with this nitrogen atom. Fine. Same way, same story for this nitrogen atom and this hydrogen atom. Okay, these 2 electrons are being shared respectively of each atom. These 2 electrons are being shared respectively of each atom. Now what is happening here? There is sharing of electron pairs between nitrogen and hydrogen atoms in such a way that each nitrogen atom is sharing, okay, 3 electron pairs with each hydrogen atoms, okay, with one hydrogen atom respectively. Okay, so this nitrogen atom sharing an electron pair with this hydrogen atom, same nitrogen atom sharing an electron pair with second hydrogen atom, same nitrogen atom sharing an electron pair with third hydrogen atom. Okay, in this entire scenario, okay, the electrons which are going to be shared, I have just made a square around them, and now see, I'm just drawing a plus here in between. Okay, so because they are going to be shared, So this is the diagram before combination. Now what would happen after combination? Okay, I'm telling you this is going to be shared, but you would realize it when I would draw the diagram for the ammonia molecule after combination. Okay, so see, after combinations diagram is like this. What I would do is, whatever the electrons are getting shared, I would overlap the outermost shells and put those electrons in that overlapped region. Okay, so this is the hydrogen atom, okay, getting overlapped with nitrogen atom. Okay, this hydrogen atom, outermost shell getting overlapped with nitrogen atom. This hydrogen atom, the third hydrogen atom here, okay, its shell also getting overlapped with the hydrogen atom. And in the overlap now, placing these electrons. Okay, now pay attention to the symbols. Nitrogen atoms electrons are cross, hydrogen atoms electrons are dots. Correct? So dot cross, dot cross, dot cross. 3 dot crosses I have to show here. So dot cross, dot cross, dot cross. Fine. Okay. And now remaining 2 crosses on the head of the nitrogen here. Fine. C. Now count the electrons. Okay. So whatever is coming in the overlap of that atom, that is those atoms electrons. Okay. So nitrogen atoms outermost shell, whatever is coming inside that outermost shell, that's the nitrogen atoms electrons now. Okay. The shared electrons are also now that nitrogen atoms electrons, means they are shared na, so he has that authority over those electrons as well. Okay. Just like same like the hydrogen atoms are having authority over the nitrogen atoms in the same way. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, nitrogen atom completed its octet, right? In the same manner, see, hydrogen atoms overlap 1, 2, completed its duplet, means attain its inert gas, nearest noble gas configuration of helium. Okay, has 2 electrons in its outermost shell. Correct? One, it was short of 1 electron, right? So it got 1 more electron, became happy. Here 2 electrons, became happy. Here this hydrogen atom 2 electrons, became happy, because hydrogen becomes happy with having 2 electrons in its outermost shell. In short, it becomes stable having 2 electrons in its outermost shell. Why? Because it reaches its nearest noble gas configuration. The simple logic. So see, nitrogen is attaining octet, getting stable. Hydrogen is attaining duplet and getting stable. So in this manner, they combine with each other. These 4 atoms combine, okay, resulting into the formation of now how much covalent bonds? See here, 1 shared electron pair between nitrogen and hydrogen atom. So this is 1 covalent bond. Okay, here again 1 shared electron pair between nitrogen and hydrogen, so another covalent bond. And here again 1 shared electron pair between nitrogen atom, so again 1 covalent bond. Oh, so by looking at this, don't say that this is a triple covalent bond. Okay, there is a single covalent bond between the nitrogen and hydrogen atoms. Okay, there is a single covalent bond between this nitrogen and hydrogen atom, because there is 1 shared pair of electron. Okay, then there is a single covalent bond between this and this nitrogen and hydrogen atom. Okay, single covalent bond between this nitrogen atom and this hydrogen atom. Okay, since there is 1 mutually shared pair of electron, so this means that 3 single covalent bonds are there. Correct? 3 single covalent bonds, right? And in between whom and whom? Nitrogen and hydrogen atoms. Fine. So this thing you need to understand. Clear how it is formed? Slightly tricky, slightly new to you, but yes, this is how ammonia is formed. Okay, now moving ahead to the next covalent compound, okay, or you can say covalent molecule as well, water. Now how water is formed then? Okay, how this hydrogen and oxygen atoms are combined? Let's see. Okay, so here it is having 2 hydrogen atoms in water and 1 oxygen atom. We all know now this, like right from the 6th standard. So oxygen atom we have already studied. Okay, so that's the reason I have come through the sequence. First we have studied the formation of simple covalent molecules. Okay, only having 2 atoms in that molecules. So in that only we have studied oxygen is short of 2 electrons from its nearest noble gas configuration of neon, right? 2 electrons. Here hydrogen is, we all know it is short of 1 electron. Okay, fine. Now something has to be done so that all these 3 atoms, okay, become stable, attain their nearest noble gas configuration. So what is happening here? The oxygen atom here, okay, in this way, I'm just drawing it here. Then I'm drawing hydrogen atom here and another hydrogen atom here. Fine. Simply, and then showing the outermost electrons of all the 3 atoms. So hydrogen is having in its only shell 1 electron, in its only shell 1 electron. Okay. Left with the oxygen, then oxygen's electronic configuration is 2,6, so 6 electrons in its outermost shell. So here 1, 2, 3, 4, and I'm drawing deliberately this 5th and 6th electron like this. Okay, why? Because see, oxygen is short, this oxygen atom is short of 2 electrons, both the hydrogen atoms are short of 1 electron. So if this oxygen atom, okay, shares it 1 electron with this hydrogen atom, and it's this another electron with this hydrogen atom, okay, what would happen? This hydrogen atom would get 2 electrons, would become happy, would become stable. This hydrogen atom also would get 2 electrons, would become happy, would become stable. Fine. And in this way, our oxygen would also become stable. How? See, 1, 2, 3, 4. And since this is also shared pair of electrons, so it would also include in its shell. So 5, 6, 7, 8, same way. Okay, so 8 electrons in its shell, outermost shell of oxygen. So oxygen also getting stable. So now let's draw the after combination diagram. Okay, so it's very simple. Once you understand the before combination diagram, after combination is like a piece of cake, showing just the overlaps and the electrons which are being shared in that overlapped region. So here dot cross here in between this oxygen and hydrogen atom. See, dot cross between this oxygen and this hydrogen atom. Okay, just pay attention to this thing. Don't while drawing the diagram, don't show the electrons, okay, in the opposite scenario. The oxygen's electrons are cross, so it should be close to the oxygen only. Okay, so don't do this. If suppose if I have done like this, so now here what I have done is I have shown in this way, in this manner. So what I would do is simply, in order to avoid the confusion, I would do like this, x dot x dot. Okay, that was also correct, which I have drawn, because it was not denoting, it was like this in the horizontal manner. Okay, I have denoted the electrons. Okay, but this one is like pretty much clear. Okay, because the electrons of that atom are closer to that atom. Okay, but no need to do it this way compulsorily. Okay, whatever, in whichever fashion you just depict it, you just do it. Okay, that means the same thing, but in order to make it look like presentable and easy to understand, what you do is I have told you in this way. Okay, show the electrons of that particular atom close to that atom. Okay, that would help. So this way. Okay, crosses of oxygen atom and then dots of hydrogen, and now remaining 4 electrons of oxygen atom. Okay, on the top, at the bottom, like this. So 1, 2, 3, 4, 5, 6, 7, 8, oxygen is happy, hydrogens 1, 2, this hydrogen atom 1, 2. Okay, so this is how our water molecule is formed. Now in this formation, what is happening here? One pair of electrons is being shared between oxygen and hydrogen atom. So this is a single covalent bond between oxygen and hydrogen atom, right? And here also one pair of electron is there between oxygen and hydrogen atom. So again, single covalent bond between oxygen and hydrogen atom. Okay, so in this way there are like 2 single covalent bonds in water. Okay, 2 single covalent bonds. Clear? Okay, now moving ahead, carbon tetrachloride. Here also we need to think slightly, okay, out of the box, just in order to understand how the electrons are being shared. Rest all things remains the same, every single concept. So here carbon, 1 carbon atom, 4 chlorine atoms. Okay, so chlorine atoms are like short of 1 electron, right? They're short of 1 electron from their nearest noble gas configuration. Carbon here, okay, its electronic configuration is 2,4. Now since it's for first time we have seen carbon, so I'm writing its electronic configuration. Okay, 6, 2,4. So it is short of 4 electrons from its nearest noble gas configuration of neon. Okay, so I would just write here, okay, carbon 4 electrons. Now what they can do? 1 carbon atom, 4 chlorine atoms. Correct? 1 carbon atom, 4 chlorine atoms in carbon tetrachloride. Now they would arrange in such a way that the carbon atom here, it would be at the center. Okay, I need to just draw this slightly smaller in order to accommodate carbon. Fine. And then the 4 chlorine atoms on the 4 sides of carbon atom. Now what we have to do is just show the electrons which are present in the outermost shell of each atom. So carbon's atom is having 4 electrons in its outermost shell. So I'm just showing it in this way. Okay, pay attention. 1, 2, 3 and 4. Okay, you would get to know why I'm doing this, why I'm showing 4 electrons in the 4 directions. Now here for chlorine, I will make 3 pairs of electrons, put it here on the 3 sides, and the 7th electron, okay, 6 electrons and then 7th electron, because chlorine's electronic configuration we all know, 2, 8, 7. Okay, so 7 electrons in the outermost shell, so 7 electrons I'm showing in this fashion. 6 electrons in pairs, 1 electron not in the pair. Okay, in the same way, 1, 2, 3, 4, 5, 6 and 7th electron here, closer to the electron of carbon. Okay, just simply to make you understand and to make the representation of the diagram easier, we are doing these things. Okay, and then here in this way, and here is the 7th electron. Okay, got that point? So now what would happen? Each chlorine atom here, it would share its 1 electron, okay, with carbon atom, each chlorine atom. And carbon atom would share its 4 electrons with the chlorine atoms, with the 4 chlorine atoms. Okay, which means carbon atom shares its each electron with a chlorine atom. Okay, see here. So this 2 electrons, this 2 electrons, this 2 electrons and this 2 electrons, okay, would get shared. This cross means the electron which is shown by cross of chlorine atom, and electron which is shown by dot of carbon atom. Okay, this is getting shared. This same manner, all the 3 pairs are also getting shared. Okay, this carbon's electron, chlorine's electron, carbon's electron, chlorine's electron, carbon's electron, chlorine's electron. Now what would happen? See, these are 6 electrons. Shared electron are also counted now, okay, for the chlorine. So now it also has that means like influence on that shared electron as if it's its own electron. Okay, so we can now count this shared electron as its own electron of the chlorine. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Same manner, 6, 7, 8, 6, 7, 8, 6, 7, 8. So chlorine atoms octet is complete. And pay attention here, see, 2, 4, 6, 8. Carbon atoms octet is also completed. Okay, so this type of sharing takes place between the carbon atom and 4 chlorine atoms, and then it results into the formation of covalent bonds between the carbon and the chlorine atoms. Now how covalent bonds? By looking at this diagram also I can tell you, or you can also tell me now, because now we have seen so much atomic orbit structures. So see, 1 shared pair of electron, so 1 single covalent bond between carbon and chlorine. Same way, 1 single covalent bond, 1 single covalent bond, 1 single covalent bond. So 4 single covalent bonds between carbon and the chlorine atoms. Correct? So let's depict it. Let's just represent it or draw it. Okay. So chlorine overlap, carbon overlap. So I'm just drawing 4 circles initially. Outermost shells of chlorine. Now just let's show the electrons. Okay. So dot cross. So dot cross, dot cross, dot cross, dot cross. Fine. And then remaining crosses, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. Done. Okay, so 6, 7, 8, this chlorine atoms done. 6, 7, 8, 6, 7, 8, 6, 7, 8. 8 electrons for all the 4 chlorine atoms attained the nearest noble gas configuration. Okay, because it was short of 1 electron, so got its 1 electron. Okay, this chlorine got 1 electron from the carbon, this chlorine atom got 1 electron from the carbon, this chlorine atom got 1 electron from the carbon, this chlorine atom got 1 electron from the carbon. Okay, so all the 4 chlorine atoms got 1 electron each. Carbon atom also got 4 electrons. Finally, see, these are its own electrons, dots, and see, 1, 2, 3, 4, 4 crosses, which means 4 electrons of chlorine atoms are in the carbon's hold now. Okay, so carbon is also having 4 electrons in its now outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 4 extra electrons. So it was already having 4, now it is having 4 extra, so total is 8. It has also attained its nearest noble gas configuration because it was requiring 4 electrons more to attain the nearest noble gas configuration, and now it has got that 4 electrons from the each carbon atom. Okay, 1 electron from each chlorine atom, sorry. Clear? So in this manner, 4, see, single covalent bond, single covalent bond, single covalent bond. Okay, oh sorry, I'm just showing the vertical lines. Single covalent bond, single covalent bond, single covalent bond, and single covalent bond. So 4 single covalent bonds between carbon and the chlorine atoms. Clear? Okay, now we are going to see the atomic orbit structure and formation of the last covalent molecule or last covalent compound, okay, which is methane. Okay, now this is a type of like brainstorming activity for you, okay, or brainstorming question for you. Means it's like very simple. You just need to make your brain run by trying to draw the atomic orbit structure for methane, and I definitely know you would able to draw this atomic orbit structure when you would first figure out how it is going to get formed. Okay, so in short, you need to figure out how it is going to get formed, draw its atomic orbit structure. Okay, the concepts are like almost the same, okay, for covalent bonding, whichever concepts we have studied, how the molecules are getting formed. Plus I'm giving you a hint for you to try on your own. It is like almost same as that of the carbon tetrachloride. Okay, so pause the video here, please give it a try. Fine. Okay, so I hope you would have tried. Let's see how the methane molecule is formed. Okay, if you would have, now after seeing the answer, if you are right, great. If you are wrong, no worries. Learn from your mistake, learn from what you did wrong, and then move ahead, right? Okay, chalo. So methane is made up of 1 carbon atom, 4 hydrogen atoms, right? So here this is 1 carbon atom, 4 hydrogen atom. Now we know the carbon atom, okay, when we are talking about 1 carbon atom, its electronic configuration is like 2, 4, so it is short of 4 electrons from its nearest noble gas configuration of neon. Okay, so short of 4 electrons. And hydrogen atom, we all know each hydrogen atom is short of 1 electron from its nearest noble gas configuration of helium. Correct? So now we need to take care that all these 5 atoms, okay, attain their nearest noble gas configuration after sharing of electrons. Correct? Now how they would share? So the same way, see, as that of the carbon tetrachloride. Okay, carbon atom, then here the hydrogen atom, okay, oh, I just made the nucleus pretty bigger. Hydrogen atoms nucleus, hydrogen atom, here hydrogen atoms nucleus, hydrogen atoms nucleus, hydrogen atom. Clear? And here in center there is carbon atom. So now I am going to show the electrons in the outermost shell of each atom. So carbon atom's outermost shell is having 4 electrons, so 4 electrons. Hydrogen atoms outer shell are having 1 electron each. Tick 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 tick. Correct? Now you can see from the figure itself, you would have got the hint. It would be easy for you to understand that, see, this electron pair, this electron pair, this electron pair, and this electron pair are going to be shared, okay, between the carbon and the hydrogen atoms. How? See, the electron of this hydrogen atom, it would share with this carbon atom. This carbon atom would share this electron with this hydrogen atom. In the same manner, it's applicable to all the 3 pairs of electron. Okay, and what would happen is each hydrogen atom, see, after after doing this sharing thing, okay, between these 5 atoms, that is carbon and 4 hydrogen atoms, each hydrogen atom would have, see, 2 electrons in its outermost shell, because that shared electron would also get counted for that hydrogen atom, we all know. So 2 electrons, 2 electrons, 2 electrons, 2 electrons, hydrogen atoms happy, each hydrogen atom happy. And then one carbon atom, it needs 8 electrons in its outermost shell. So see, 1 2 3 4 5 6 7 8. Oh, it's also happy. Okay, so let's make it more clear for you to understand by drawing the atomic orbit structure after combination. Okay, so this is carbon atom. Now here the overlap, here the overlap, here it's the overlap, here it's the overlap of hydrogen atoms outermost shell. I'm showing here. Fine. In the overlap, we all know what we are going to show, the shared electrons. Okay, so carbons are with dot, right? So dot, 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 dot. Hydrogens are with cross. Okay, so cross, 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 cross. Fine. Now see, oh, this is dot. Now see, this hydrogen atoms in its outermost shell, okay, in its only shell, sorry, whatever electrons are coming in that overlap, it's are now that hydrogen atoms over electrons. Okay, so hydrogen atom 2 electrons, hydrogen atom 2 electrons, hydrogen atom 2 electrons, right? Hydrogen atom 2 electrons. Fine. And for carbon also the same thing, in its inside its outermost shell, whichever electrons are there, that is now that carbon atom's electron. Okay, apart from its own electron, whichever are the shared electrons, that also we should count now. Okay, so that are also now the shared, so that's why they are also present in its outermost shell now. Okay, so 1 2 3 4 5 6 7 8, 8 electrons, correct? So it has also attained octet in its outermost shell. Clear? So with this, the carbon atom is forming how much? 4 single covalent bonds. See, correct? This shared, one mutually shared pair of electron means 1 single covalent bond, 1 single covalent bond, 1 single covalent bond, 1 single covalent bond. So 4 single covalent bonds, okay, between carbon and the hydrogen atoms. Clear? Okay friends, now let's see some questions. Okay, very simple questions, so that you would get an understanding, okay, of what all things we have studied. So give 2 examples each of the covalent molecules. Fine, 2 examples each of covalent molecules having same atoms, having different atoms. So let's give 2 examples. See, the covalent molecules having same atoms, 2 examples: H2 molecule, Cl2 molecule, or like H2 molecule, O2 molecule. Fine. And covalent molecules having different atoms, there are also 2 examples. So different atoms, like suppose HCl or like carbon, 4 hydrogen atom, methane. Okay, so covalent molecules having different atoms, okay, which means atoms of different elements. Now what they are asking us, oh, one more thing is there, right? So I will just write it above, HCl methane. Fine. Now for each example also write the type of covalent bond: single, double, triple. Oh, so now you would think, sir, we need to wisely write the examples of the covalent molecules, right? Because if we don't know which type of covalent bond is present in them, then we are stuck. But why won't you know? Because we have whatever the covalent molecules we have studied till now, the 9 covalent molecules. Okay, out of that only you give the examples, and if at all you would have studied them very nicely, if you have understood how they are formed, you would definitely tell which type of covalent bond is present in them. Okay, whether single covalent bonds or double covalent bond or triple covalent bond, right? So for hydrogen atom, we know there is a single covalent bond, correct, when it is formed, because only one mutually shared pair of electron is there. Okay, so here it is single. For oxygen, it's double covalent bond, right? We have seen, see, oxygen, right, double covalent bond, correct? So here oxygen double, I'm just writing D. Then again HCl, so it's again single covalent bond, because only one mutually shared pair of electron is there between hydrogen and chlorine atom. See HCl, you can see one mutually shared pair of electron, so single covalent bond. And the last one we wrote was methane. So we have seen between each carbon and hydrogen atom, which means between each hydrogen atom and a carbon atom, okay, there is a single covalent bond. Each hydrogen atom and carbon atom, each hydrogen atom and carbon atom, each hydrogen atom and carbon atom, single covalent bond. So 4 single covalent bond, which means simply it has single covalent bonds, right? So which type of bond here? Here also it is single covalent bond. Okay, fine, done with the question. Next, an element A has 1 electron in its first shell. Yes, one more thing. Whenever I come up with a question, pause it there itself, okay, and then try to answer it on your own. Just try to make your brain run. That's it. Okay, so for this question also, an element A has 1 electron in its first shell. It combines with element B. Okay, so element A has 1 electron in its first shell. A has 1 electron in its first shell. Fine, this is the first shell of A. This is the nucleus of A. Okay, you can just pause the video here. You can read the question on your own. Try to solve it on your own. Okay, so I hope you would have solved. So now let's solve. Okay, the question. Let's see your answer is right or wrong. So an element A has first electron in its shell. Fine, 1 electron in its first shell. It combines with the element B having 7 electrons in its third shell. Okay, so there is an element B, first, second, third shell. 7 electrons are there in its third shell. Okay, so I will just draw this 7 electrons. Okay, 1, 2, 3, 4, 5, 6, 7 in this way. So this means that since it is having 7 electrons in its third shell, its inner shells are also completely filled. Okay, it means its inner shells are also filled, right? So 2 maximum capacity of first shell, 8 maximum capacity of second shell. So 4, okay, 1, 2, 3, 4, 5, 6, 7, 8. And then the last shell is having 7 electrons. So can you just correlate what type of bond would be formed? Okay, since it is having 7 electrons in its third shell, so no need to figure out the electrons which are present in the inner shells also. That way also you can just figure out. Okay, how? Suppose if I am erasing this, okay, no need to care about how much electrons are there in the inner shells. You know that it is having 7 electrons in its outermost shell. The another atom A, okay, it is having 1 electron in its first shell. Okay, so this is something like which is correlating with hydrogen atom, right, having 1 electron in its first shell, and chlorine atom, right, having 7 electrons in its outermost shell. And what happens between hydrogen and chlorine atom? Okay, this atom desperately wants 1 electron. This atom desperately also wants 1 electron. Okay, there make one correction, simple correction here. An element A has 1 electron in its first shell, which is its only shell. You can just add this, which is its only shell. Okay, so that would be, then the question is like complete then. Okay, showing, giving the complete info. So this atom's only shell is having first only 1 electron. Okay, this atom's third shell is having 7 electron. So if at all, if we don't also correlate with hydrogen and chlorine, then also we can figure out its only shell is having 1 electron, its last shell is having 7 electrons. It needs desperately 1 electron to make its outermost shell having 8 electrons. Correct? B. A, since its only shell is having 1 electron, okay, and this is the first shell, so first shell's maximum capacity is like 2, so it also needs 1 electron. Then A also needs 1 electron, B also needs 1 electron. What they would do? Share the electron. So A would share its electron with B, B would share its electron with A. Now what would happen? There would be a sharing of a pair of electron. When there is now, see, here is mutual sharing. A is also sharing its 1 electron, B is also sharing its 1 electron. Okay, and then we see that there is a pair of electron getting shared. So in a pair, 1 electron is contributed by one atom, another electron is contributed by another atom. So that is called mutual sharing, I have told you. So this mutually shared electron pair is mutual sharing of electron pair is taking place. And we know whenever the bond is formed and such mutual sharing of electron is taking place between the combining atoms, which type of bond is formed? Covalent bond. So what type of bond is formed here? Covalent bond, right? So no need to correlate to hydrogen as well as hydrogen or chlorine. Okay, we can go it in this way. We can get to the answer in this way also. Clear? Now draw the atomic orbit structure. For now this purpose, Now I can redirect you to the atomic orbit structure of hydrogen chloride, okay, HCl. Why? Because both these atoms are exactly the same as that of A is same as that of the hydrogen, having 1 electron in its only shell. B is same as that of the chlorine, having 7 electrons in its outermost shell, okay, in its third shell, sorry, okay. So they are also sharing 1 electron, right? Means they would obviously share 1 electron pair with each other. So the diagram would be exactly same as that of the hydrogen chloride or hydrochloric acid, whatever you can say, okay, HCl. Clear? Both are correct. Clear? So the diagram would be same as that of HCl. Okay, so you can refer the diagram of HCl, right, by going back in the video. After you have tried to draw its atomic orbit structure, because see, almost before combination structure I have drawn, what you need to draw is just make the overlap of these two shells and show these 2 electrons in that overlap. Rest thing is done, already done. Correct? Okay, so friends, with this we have reached the end of this video. I hope you would have enjoyed learning with me. You would have understood the concepts which we have learned so far of covalent bonding. And yes, with this we have studied all the concepts of this chapter, atomic structure and chemical bonding. Okay, so as you all know, learno matlab free hai par best hai. So see you in the next video with the next chapter's concept. Till then, keep studying, stay safe and have a great day.